Philippines is blessed with abundant water resources. But water shortage is a glaring reality, especially during the dry season. On the other end of the spectrum, extreme rainfall during the wet season results in massive flooding. Many factors play a part in these seemingly opposing realities. As populations grow and areas become urbanized, more and more people, communities, and businesses need and demand clean, safe water. Often, the supply of water cannot cope with the growing demand. This leads to water shortages and uneven distribution throughout the country. Likewise, improper waste disposal and untreated wastewater discharge pollutes water bodies and reduces the availability of clean water. While excess water from increased rainfall brought on by extreme weather events should ideally be stored for later use, especially during the dry season, this opportunity for maximum use of the resource is not optimized. Instead, extreme rainfall has resulted in repeated flooding and widespread damage, translating in economic losses and loss of life. The glaring truth is that we are left with no choice but to face these challenges head-on, and, like ripples on the water's surface, create lasting and far-reaching solutions. The Philippine Development Plan, or PDP, the nation's blueprint for achieving inclusive growth and poverty reduction, includes strategies in pursuit of water security. An overarching strategy of the PDP towards ensuring water security is the use of eco-efficient approaches and interventions to enable the Philippines to use its water resources in the most economically efficient and environment-friendly way. This is seen to ultimately help enhance the country's competitiveness and increase productivity in the industry and agriculture sectors. Through innovative interventions and technologies, the eco-efficient approach can also be a major strategy in dealing with the challenges of climate change and disaster risks for sustained economic growth and poverty reduction. Certain sectors have already risen to the call. Various projects of the public and the private sectors have been developed to address water problems, both the shortage of water and excess water during time of heavy rainfall. Local communities and the private sector have also built wastewater treatment facilities in urban and industrial communities in order to reuse dirty water and to ensure water quality. To protect flood-prone areas, especially during the typhoon season, flood management structures such as permeable surfaces and catch basins are being built. However, in order to optimize water as a resource, these floodwater catchments would need to put in place facilities to enable the reuse of water. To integrate the eco-efficiency concept into water resources development and management, the National Economic and Development Authority, with the assistance of the United Nations Economic and Social Commission for Asia and the Pacific, formulated the Eco-Efficient Water Infrastructure, or EEWIN, Strategic Roadmap. Applying the concept of eco-efficiency means maximizing the efficiency of water resources within the ecosystem through innovative infrastructure and systems. Eco-efficiency combines economic development and environmental quality through sustainable processes of design, construction, operation, and maintenance with less environmental and cost impacts. Simply put, EEWIN provides integrated long-term solutions that create all-around higher value with less impact on the environment. One of the simplest innovations to boost water supply is rainwater harvesting. This involves collecting water from surfaces on which rain falls and storing it for later use. This is ideal and achievable for use in flushing toilets and irrigation, such as that successfully installed in the Philippine Science High School campus in Cebu. In Nuvali, the country's largest self-sustainable and eco-friendly community found in Santa Rosa, Laguna, the usual concrete or asphalt pavements have been replaced with permeable surfacing. The porous material allows stormwater to seep in to prevent flooding and recharge the groundwater aquifer. Founded on its vision of sustainable living, this master-planned community in Santa Rosa, Laguna integrates technologies that work together to create an ideal and greener environment. Bioswales are landscape elements or linear rain gardens designed to receive, absorb, and filter stormwater from driveways, sidewalks, parking lots, and rooftops. Artificial lakes serve as catch basins of filtered runoff, while providing pleasant views and recreational features for residents. In the agriculture sector, small farm reservoirs provide farmers with a low-cost way of providing extra water for a single farm, especially during the dry season. A reservoir can be as small as 300 square meters or as large as 2,000 square meters. Water impounding dam structures collect rainfall and runoff and can be constructed by manual digging or basic equipment. Irrigation is done through PVC siphon pipes or pumps. All SM malls have wastewater treatment facilities using sequencing batch reactor technology. This takes up less space and uses less energy than conventional systems, since all processes take place in a single batch reactor or tank in a timed sequence. Oxygen is initially bubbled through the wastewater to encourage the growth of aerobic bacteria that clump together in groups known as flux or sludge as they consume the organic pollution. After a time, the sludge is allowed to settle to the bottom of the tank. Without disturbing the sludge, water near the surface is then released or discharged for reuse in irrigation, gardening, and other non-potable purposes. The Muntinlupa Public Market Wastewater Treatment Facility utilizes a hybrid technology consisting of SBR and anaerobic baffled reactor or ABR technologies that are low cost and low maintenance. Construction cost of the facility is only a third of conventional treatment plants, while operational and maintenance costs amounts to only half of conventional plants. Since the facility was completed in 2006 at a cost of 6.8 million pesos by the local government of Muntinlupa, with technical expertise provided by USAID and financial advice by the Planning and Development Collaborative International Incorporated, water pollution has dropped dramatically from 600 milligrams per liter to less than 30 milligrams per liter. The city has also been saving more than 15,000 pesos monthly on water reuse. With this hybrid technology, a maximum capacity of 210 cubic meters of wastewater coming from the market each day is treated. To protect Bonifacio Global City against torrential rains and floods, its flood catchment basin located underneath Burgos Circle gathers runoff in the area into a detention tank 5 floors deep. The water is later pumped into creeks that lead to Manila Bay. The Blumentritt Floodwater Interceptor project is currently being built by the DPWH to manage flooding, especially in the flood-prone areas of UST and in Quezon City. The 3.3-kilometer-long and 2-meter-deep culvert is more than 50% complete. When finished, it will divert flood water from Quezon City that goes to the Sampaloc area in Manila, draining it towards Manila Bay. In future flood management projects, the reuse of stormwaters may be explored to optimize the use of the resource. In Japan, flood control has been integrated seamlessly into community life and infrastructure. The Churumi Multi-Purpose Retarding Basin, in addition to its primary purpose of protecting its populace from flooding, features a wide-open space used for recreation fields, sports facilities, venues for competitive events, as well as a lush natural park for local residents. The area covers 84 hectares with a storage capacity of 3.9 million cubic meters. Even as water flows into the basin, an elevated main road connects all sides and can be used even during flooding. Device and display boards are also installed within the basin to detect and warn people about dangerous situations during floods. The Integrated Stormwater Management or ISWM project under the Department of Science and Technology Region 7 is a comprehensive system that combines a catch basin, flood prevention, and water treatment facilities. The ISWM is integrated in DOST 7's S&T complex in Lahug City, Cebu. With a total investment cost of roughly 2 million pesos in 2010, the whole system is low maintenance yet high efficiency. Aside from control of stormwater damage, long-term benefits and savings come from reduced construction of water supply facilities, reduction of unnecessary investment in overlapping infrastructures, reduced water and energy demands, and health services. With all these successful examples of eco-efficient water infrastructure, it is indeed time for us to take a broader perspective and work together to reassess how we see development and welcome innovation in our planning and design processes. EEWIN is a strategic approach to sustainable development and proves that economic growth and environmental quality can go hand in hand. EEWIN is also consistent with the concept of value engineering or value analysis, which aims to optimize resources and investments, reduce life cycle costs, and expand the functionality of a project without compromising its intended objectives. In simple terms, eco-efficiency is about being able to do more with less, better value at lower cost, and environmental impact. EEWIN requires not just smarter but wiser decisions, working together through partnerships, legislation, investments, education, and other means to secure water sustainability and sufficiency. But the time to act is now. Time to win the battle against water resource challenges. Time for EEWIN.